So again, no plus or minus needed for today's lesson because you're taking the square. This only happens when you take the square root. Extraneous solutions, you'll see them whenever you have the square root equal to a negative number. Okay, so once you get to this point, that means there is no solution or the solutions are extraneous. So let me give you the plan on how to solve these equations today. There are 3 steps. Step number 1, you are going to isolate the radical or the square root. And this has to be equal to a positive number, not negative. So this should not be equal to a negative number for this lesson today. Okay, so isolate the radical. That's the first step. The second step is you are going to take the square. So instead of taking the square root, you're going to take the square so you can cancel the square root. So the square is the reciprocal of the square root. So you square both sides of the equation. So both sides of the equal sign. Okay. Let's see what else. Step number 3, you're going to solve. So this part you've been doing since algebra 1 and even before algebra 1. So watch how simple this is. So I'm going to first, I'm going to add 12 to both sides, which means I'm going to move this 12 to this side. I'm adding 12 to 0, and that is equal to 12. So then all I have left on this side is the square root of x. So notice, step 1 is done. Isolate the radical is isolated. Step 2 is you're going to take the square. You're going to take the square of this side, which is the inverse of the square root, and also the 12. So then the square and the square root cancel each other out. So then that just gives you the x by itself. And when you take the square of 12, that is equal to 144. And this is the solution to this equation. Okay. Let's do example number 2. Same process. We need to isolate the radical. There's a positive 1 in front of it. So that means we move the 1 to the other side of the equation. So you subtract 1 from 5. So then the 5 becomes a 4. So now we have the square root of x on this side. So as you can see, the square root of x is isolated, or the radical is isolated. Then we go to step 2, which is you take the inverse of the square root, which is the square. So then this cancels the square root, so it gives you x by itself. And then when you square 4, that's 4 times 4, which is the same as 16. So this is the solution to example number 2. Okay. Example number 3 is a little bit different because you have an 8 in front of the radical. So still move this 1 to the other side, which means subtract 1 from 3. So then that 3 becomes a 2. And then now we have 8 times the square root of x is equal to 2. Now, before you take the square, instead of taking the square, let's divide by 8. So I'm going to divide by 8 on this side and also the 2. So then this gives me the radical by itself. So the square root of x is equal to 2 over 8 reduces to 1/4. But now I want to cancel the square root, so I'm going to take the inverse of the square root, which is the square. So I'm taking the square of this side and also of the fraction here. Okay, so this gives me the x by itself. But now watch this. This is the same as 1 square over 4 square. 1 square is the same as 1 times 1, which is still 1. But 4 square is 4 times 4, which is equal to 16. So be careful with taking the square of a fraction. You have to apply the square to numerator and denominator. Okay, so this is the solution to this square root equation. Let's go to example number 4. I'll be done maybe in less than 5 minutes. Okay, for example number 4, again, there's a 16 on this side. I'm going to move that 16 to the other side by subtracting 16 from 1. So then that 16 becomes a negative 15. Then we have a 5 in front of the square root of x. So we divide by that 5. So we have the radical by itself. So then this gives us the square root of x is equal to a negative 15 divided by 5 is negative 3. Now watch this. Remember I said here, extraneous solution if the radical is equal to a negative number. Okay, so in this case we have a negative number. That means the solution is extraneous, or you can also say there is no solution. And I don't know if you guys remember the reason why. The reason why is because if x is negative, then that number is not a real number, it's a complex number. So there's an I involved. Okay, So you can also check this for sure. So if I continue to solve this equation, don't write this down, okay? I'm just going to show you why this will give you false statements. So don't write this down. So I'm going to take the square of the square root and also take the square of -3. So then this says that x is equal to 9. So when I check the solution, I'm going to check the solution x equals 9. Let's see if I get a true statement, okay? So I'm going to come to this equation. So there's a 16 here. That's a 16 plus 5 times the square root of, instead of x, 9. This equals, okay, 16 plus 5, the square root of 9 is 3. So 5 times 3. And 5 times 3 is 15. So we have 16 plus 15. 16 plus 15 combined to 31. And this, as you can see, is not equal to 1. So that's why there is no solution. So even if you work through the problem, when you check the solution, you'll get a false statement, which says that 31 is equal to 1. But this is false. Therefore, there is no solution to this equation. So that is why there is no solution. As soon as you see a negative number on this side, then you can stop right there and say there is no solution. Okay? All right, and that's the reason why. Example number 5. So for this one, I'm going to subtract 4 from both sides of the equation. So I do 4 minus 1, so then that becomes a -3. And that equals negative square root of 3x plus 4. Now this one can also trick you, because you might think, well, that's a negative number. But notice, this radical has a negative lead. So we need to make that radical positive. And the way we do that is by dividing by -1 on this side and also on this side. Okay? So then this changes to +3. And now the radical is positive. So the positive square root of 3x plus 4. From here, once the radical is isolated, this is when we take the inverse of the square root. So we take the square of this side, but also take the square of 3. And 3 squared is the same as 3 times 3, which is equal to 9. And then this gives you what's inside of the radical, which is just 3x plus 4. This is a linear equation. So then let's subtract the 4 from both sides of the equation. So then that 9 becomes a 5. So 5 equals 3x. Since we want x, not 3x, then we divide by that 3. So then in the end, we find that the solution to this equation is x equals 5 over 3. And that's all for this example. Okay? Right, last example. Notice that this radical is isolated on the left side, and this radical is isolated on the right side. So what happens when you have two radicals on both sides of the equation? This is what happens. All you have to do is, since this is isolated and this is isolated, you go to step 2. Take the square of this radical, or square root, and also take the square of this square root. So all that's going to do is it's going to cancel the radical. So then that gives you just 2x minus 1, which is the radicand of the number inside of the expression inside of the radical. And this gives you x plus 7. So once you get to this point, you're solving for x. You do what you know how to do, okay? So I'm going to subtract x from this side and also from 2x. 2x minus x is x, and the x's cancel here. So x minus 1 equals 7. Since I'm solving for x, I'm going to add 1 to both sides of the equation. So then we find that x equals positive 8, okay? So then this is the solution to this equation. Any